Hey, in this video, let's use coroutines to animate something in our scene. How about like a panel that shows up when you press escape and goes away when you press escape again. So maybe it slides onto the screen and then slides off of the screen. So I'm in Unity and I'm in my tank battle project. I'm gonna create a canvas for this object. Let's see, canvas, and I will make a panel. Alright, switch into 2D mode and take a look at my panel. Let's make this stand out really well. Okay. Alright, seems fine. Let's leave it like that. So I want to make this panel move, and so I'm going to need a script in order to tell it how to move. So let me create a C# script. I'll call it UI hider. That sounds pretty good. UI hider. Let's load that up. Okay. So what I'd like to happen is first of all, I need to make some properties so that the user has some control over how this thing shows up in the first place. I'm going to make a Boolean that says hidden, and we'll start that off as true. So it starts off by default hiding this object. So when this script starts off, let's keep track of the position. Vector 3. Let's see about that. All right, transform.position. That's what I want to store, so that we can get back to that position. All right. So on start, we will store that position, and then if hidden, we'll move this thing. We'll set our position. We're going to need a hiding position. So let's say make a transform hidden position. I'm going to make this position private because it doesn't need to be exposed. Alright, hidden position dot position, because it's actually a transform. I just use ridiculous naming for that. So if it's hidden, we'll set it to its hidden position, and then we need to expose just a couple of functions. Public void, let's have show, and let's have hide. Okay. So I want this to show up when I press escape. So actually I could use the update function right here for that. Let's say if input dot key down, get key down, key code dot escape. All right. So if we press the escape key, then we check, are we hidden? If we're hidden, then show. Otherwise, hide. There we go. So at some point, show has got to make it so that hidden is false, and hide has got to say hidden is true. Okay. And now I need to make the actual animation happen. I want this position to change. The transform.position is going to change over time. For this, I'm going to launch a coroutine from this show function. So let me write that coroutine first. Let's see. It needs to be enumerator. I'll call it do show, and let's see, what I would like to do is start off by doing sort of like a linear interpolation. Let's start off at 0, and then we're going to set our position. Transform dot position is some interpolation, vector3.lerp, between the original position and the hidden position. So hidden position dot position, and then our position variable, our original position. I want to interpolate between them using t. Now I want to do this as long as this as long as it takes, I guess. I want to just increase this t by something related to the time it's been taking. Alright, so this would take 1 second to go from 0 to 1, which is fine for now. I can change that, multiply it by some scale factor if I want to control that further. And then I can do this interpolation in a loop. So let's say while t is less than 1. We'll just keep doing this. Now, I could use, I need to have a yield instruction in this coroutine, but I could use wait for seconds, but I'm going to do yield return null. So this is saying just give up execution, and it'll get that execution back as soon as possible. So essentially 1 frame. It'll wait until next time around for it to run this coroutine again. So we'll get our position starting at the hidden position. We'll increase our t, and then the next time around our t has changed, and we will get the next position. Looks pretty good. Now my show function should let's see, call start coroutine do show. Alright, and we could do a very similar one with do hide. Can start at 1 as long as t is greater than 0, and decrease it. Or we could just swap these two positions. We could also write a single coroutine that does both of them, but it's pretty clear when they're separate as well. Alright, let's start coroutine do hide. Alright, so let's see, is this right? I guess we'll find out. There may be some interesting effects here. So let me select my panel and make sure that my UI hider is on it. Should be okay. The hidden position, I need to specify something for that. So let me put a empty game object in here. Panel hiding spot. And I'll just move that down here. That seem okay? And then drop that into my hidden position. Alright. Now when I press escape, ooh yeah, looks pretty good. Slides off the screen. Some little details. If I press the escape and keep pressing it, it's not going to do exactly what I want. Whatever. Still cool. Now there are lots of other cool things I can do with this. Because I'm using interpolation, right, I have this value, this interpolation parameter going from 0 to 1. I'm using lerp, but I don't really have to use lerp. I could use any function I want, any function I design that that goes through these positions. I could make it non-linear and control this a lot better. I could design my own function. I'm actually going to try something else here. I would like, let's see, I think 0 to 1. Okay, I think I got it. So I'm still going to use lerp, but I'm going to use some other function to control this t, the result that I use for lerping. And maybe this will turn out in an interesting way. Let me expose one more variable here called an animation curve. Just going to call it curve. Alright, and then in Unity, when this reloads, it comes up with curve because I made it public, and it's a curve editor. So I can choose these built-in curves, or I can adjust it, make my own weird shape here. But this provides values all the way through this range, and you'll notice the range is from 0 to 1 on both of these axes. So it's a way of shaping my interpolation parameter. This one is ease in and ease out, so it kind of slows down on both ends, which is a pretty nice one. So let me go back to my script, and I will use, instead of t here, curve.evaluate t. And so it'll take that t from 0 to 1, and it'll give me a new value from 0 to 1 based on the curve that I've created. Nice. All right, let's try that. Okay, so it's got a little bit of a slowing down as it gets to the end, and slowly speeding up as it goes out. A little bit nicer. Cool. Alright, hope you liked that, and hope you learned a little more about coroutines and what kind of uses they have. See you next time.